This is the Hartford Civic Center case study presented by Jonathan Beauchamp, Carlo Francois, and David Wagley. Okay, so a little bit of background on the project. The city of Hartford, Connecticut decided that they wanted to draw more tourism and revenue into the city, and to do that, they built a dual-purpose sports arena and civic center that they would use for sporting events as well as concerts and the like. Vincent King was chosen to be the architect of the center, and he employed Fraioli, Bloom, and Yeaselman to design the structure. They were the structural engineers responsible for the design and making sure that it was up to code.
Hello, my name is Carlo Francois. I am talking a little bit about the design and the planning of the art center. And you can hear a music in the background. That's my daughter playing. The art center was a state-of-the-art design made of two main layers. The layers had 30 by 30 feet grids featuring steel beam placed 20 feet apart. 30-foot long diagonal members link the nodes of the lower and upper layers. These diagonal members were in additional layers of horizontal members. This design was different from the typical space frame roof design in 5 different ways. The Hartford Coliseum consisted of a geometrically double symmetry roof system. This design consists of a triangular steel lattice space grid constructed to be 360 by 300 feet, supported by 4 reinforced concrete pylons spanning 210 and 270 feet. The purlin roofing frame was supported by a W6 post toward the grid tab. Now I'm going to return it to David, who is going to talk about the failure itself.
And here's a picture just to show the magnitude of the failure.
Why did this structure fail? There were inaccuracies in many of the calculations made with design software with little or no hand verification. Prioritization of construction techniques were based on economic and not engineering and structural analysis. The lack of leadership in discovering and correcting faults played a major role in this catastrophe. The widespread poor workmanship and use of cost-cutting techniques was used quite often as well. Smaller, weaker members were used to ease the beam fitting when the construction was done, and this wasn't discovered until after the failure. There were cables used to wrap supporting signboard members, and this is just another cost-cutting example that was followed. Let's take a look at the loads and deflections. The trusses were assembled on the ground and hoisted to reduce welding costs. When hoisted, the deflections were greater than design and still approved by the engineer of record. It's much more cost-effective to weld rigid connections at ground level than it is to use cranes and hoist to position the welders. The subgrade settled when the truss was constructed on the ground and the truss wasn't properly leveled. This absence of dead level position caused disproportionate vertical deflection. The geotechnical properties were just not engineered sufficiently to support a structure of this size during the construction. The live roof load was calculated to be 64 to 73 pounds per square foot at time of weather event, when the live roof load maximum load was only 74 pounds per square foot. A much greater factor of safety should have been in place. The total live roof load was overburdened by a distributive load of approximately 1,300 kips in total. The live roof load should have been designed to support a minimum of 84 pounds per square inch. Let's take a look at the canon violations. The health, safety, and welfare of the stakeholders were not paramount in the design and the construction of the Coliseum. This is the fundamental of all canons. NSPE Code of Ethics Section 2, 1A was violated. If engineer's judgment is overruled under circumstances that endanger life or property, they shall notify their employer or client and such other authority as may be appropriate. When the client's costs became a priority and the warning signs raised by the contractors were ignored, these ethics were completely disregarded. And the absence of a structural engineer on the team violated all safety and good practices.
Here are our references, and thank you for listening to our presentation.